All right, I've literally recorded this video 15 times now. I'm gonna nail it this time though, I really feel it. All right, so we've come to the portion of the class where we're gonna learn our first kind of interesting thing, and that is variables, all right? A lot of you know variables already and you're kind of rolling your eyes at me, but we'll review it because it's actually kind of important. We're gonna be learning about primitive types. If you don't know what that means, it doesn't matter right now, but we will talk about it in a few weeks as we contrast them to object types, okay? So keep this in mind and keep it as a review and take notes on it, and we'll talk about it more and more, but it's a chance for you to really get what's going on inside of a computer. In fact, let's talk about computers from a very high level. So let's say you're an eagle or in a spacecraft 1,000 miles away and you're looking down on a computer, and what do you see? Well, you don't see anything specifically going on, but you're like, I can see that it's kind of generally, it stores numbers and it does math on those numbers and it spits out the answer. It's a calculator. It's a glorified calculator, right? A calculator, you can put a number in and you can do an operation on it with another number and then it'll spit out your answer. Okay. In fact, we used to have reverse Polish calculators where we'd go like 5 enter 6 plus. So you wouldn't say 5 plus 6, you'd say 5 enter 6 plus. And 5 enter put it into one spot in memory. Okay, so that's us storing, right? And 6 plus, well, that's us doing an operation on that stored value. Okay, and you get back the number 11. So it'd be the same thing as if you said 5 plus 6, okay? And that 11 was then restored, but that's neither here nor there. Okay, so we're storing, so one of the things we're doing is we're learning how to tell the computer what we want it to do. We're programmers, we're coders, we're creators now, right? We're not consumers. So we're going to tell the computer what we want it to do, okay? And part of that is telling the computer what data we want to store, all right? And the other part of that is telling the computer what operations we want to do on that data, okay? And that's all we're going to do. That's all we're doing this semester and next semester, and when you graduate, that's all you're going to do for the rest of your lives, okay? It's just going to be, you know, different versions of that. Okay, so let's get into it a little bit. So we have this idea of storage, right? My cousin's moving right now, and I told her to go to the container store to get some containers, and then she's like, no, cuz the container store is mad expensive. I'm not going to the container store. So don't go to the container store, but go to some sort of store, right? And get some sort of package, or not package, box. Get some sort of box, right? And the idea is, well, how big of a box should you get? Well, in my cousin's case, it depends on how much stuff she needs to pack, right? And in our case, when we're storing data, it depends on how much data we want to store, okay? So that brings us to something called a type, all right? And what a type does, remember, a memory is just a box, right? It's just a container, okay? And so one thing we want to say is we want to be able to say how big of a box we want when we store the data, right? Because the computer is going to ask that. The computer is going to say, well, if you want memory, I can give you all sorts of memory, but you have to tell me how much memory you want. All right, so we have to specify that. And the way we specify that is with the type, okay? And the other thing the type specifies is how we interpret the data inside the box, okay? Now, if that doesn't make sense right now, you can think of it as just a high level of ints are non-decimals, right? And they can be positive and negative, all right? So they're non-decimals, they're whole numbers, all right? No decimal part, but positive and negative. Floats are decimals, and we haven't used floats all that much, but for some god-awful reason, processing uses floats, so we're going to use floats too. So floats are decimal numbers, all right? And doubles are decimal numbers that have a bigger box associated with them. They have more precision. They're more precise, which means you get more numbers after the zero if you were doing a measurement on something, okay? You could represent more numbers after the zero. It's a little, I'm being a little hacky here. If you really want to know how floats and doubles are stored, well, actually, let's get into that real quickly. Okay, so what does that mean? Well, there's no difference between, if you look at any of these boxes, if you look at a box for an int and a box for a float and a box for a double, what you'll see is a bunch of ones and zeros, because that's all you have in a computer is a bunch of ones and zeros, right? There are 10 people in the world who know binary, right? I already did that wrong, right? You're not supposed to say that. Anyways, so you need to, right, be able to interpret that differently, because an int's a bunch of ones and zeros, and a float's a bunch of ones and zeros, and a double's a bunch of ones and zeros, but they're representing things that are, well, at least if you just look at ints and floats, right, they're representing two things that are completely different, okay? You're in the same kinds of ones and zeros for an int and the same kinds of ones and zeros for a float will be interpreted completely differently, okay? One's going to be interpreted as a whole number, and one's going to be interpreted as a decimal, okay? So the type tells us how big of a box you want and how you want the stuff inside interpreted, okay? Now, if you really don't want to do the hand wavy thing and you really want to know what's going on here, go look up the IEEE format in Wikipedia or something like that, and you'll see words like mantissa, and it's you can use it. You can talk about it at dinner parties. People will be really impressed. But it's beautiful and clever and ugly. So all of those things can be true at once, and IEEE floating point format is definitely one of them. Okay, so we can now tell the computer what kind of box we want and how we want it to interpret whatever's inside that box, the ones and zeros inside that box, okay? And from a high level, these three types, well, we can represent stuff that's a whole number, right? So what are some things in life that's a whole number, right? My age, I never say a decimal with my age. Well, not since, I was 5. So that's going to be represented as an int, right? But my height, that's a double, right? I don't just go with feet, I go feet and inches. So we can kind of get into doubles or floats there, right? It's a little more decimal. So as long as we know what we kind of want to represent, we know which ones of these to use, okay? So variables are named boxes, okay? We can now slap a name on the box and use that name whenever we want to reference that particular box, okay? So int x, which is my favorite name for an integer value, but it's actually a bad name because we need to do descriptive variable names, but they're not describing anything right now. So int x, all right, that's me saying I want to name this box x, okay? And I'm putting x on it, all right? And now anytime I use x, all right, the computer knows to go look inside this box and read the value inside this box. Well, what value is inside x right now? Actually, we haven't specified it. So there's some sort of bits. There's always bit sets of ones and zeros no matter on what memory you get. You never get clean real estate, okay? There's always some sort of bit pattern in there. They could be all zeros, but there's still some sort of bit pattern in there, okay? So this is an uninitialized variable, and you don't know what's inside that particular box. It's like you asked the computer to give you a box, it slapped a number on, it slapped a name on it, and it gave you the box, all right? And you don't actually know what's inside that box. It could be the number 5, it could be the number 500, it could be the number -2, or whatever it is, just depending on how these bit patterns are interpreted, okay? So what we sometimes do, or what we get in the habit of doing, is we initialize this because having some random junk in there might lead to different program runs every time we run the program, right? Because it might be some value the first time we run the program and some different value the next time we run the program, okay? And this is more general programming language stuff, right? Different programming languages might handle this in different ways. Different environments might handle this in different ways. So it's, but you shouldn't be using uninitialized variables in mathematical operations. One thing we get in the habit of doing in beginning programming is we set it to some value at the beginning, just so that we don't have this thing where it does something different each time through. Okay, so now I said int x equals 0, okay? And so what the computer does is it takes the number 0 and it puts it in here, okay? So I have x, and it's the number 0, and I've stored it in there, and now I don't have to, I've got it in my memory, all right? X is the number 0. Oh, God. Is the number 0, okay? All right? And we could do it with these other values, right? And what does 0 mean in x? Well, it's a bunch of zeros, okay, in the bit pattern. But it might be something different for these, right? Okay. So we're able to get a box, specify the size, specify how we want to interpret the values inside of it, name it, okay? And every time we use that name from here on out, it's going to jump to this particular box, all right? Right? As long as it's in scope. We're not going to talk about scope right now. Okay. So hopefully that makes sense. This is a longer video anyways. I have some questions below, and then we'll continue with variables, okay?